Time. All right, this is all about patterns, and I'll go slowly to make sure you follow along, especially when we start this thing called a memo page. And I'll talk about test grades that'll come from that and all sorts of things that you'll be glad about as time goes on. Okay, so in the last class, I drew, I hope for the last time, these 30, 60, 90 triangles, okay? And we're going to now go from geometry to trigonometry using these. So you remember that I did 30, 60, 90. We've sort of overdone maybe the special triangle ratios, and you remember them. I can make sure you remember from geometry. And these are ones that you just should know. They're very common angles. If it's 47 degrees, I'm not going to know it either. You'll get to where you can estimate it, but if I actually need to know the sine of 47 degrees, I'll have to go to a calculator, so that's okay too. I talked a little bit about people that use it in the real world, like if you had a satellite orbiting the Earth, and here's the Earth, and the satellite is right here, you would want to tilt your receivers, which really look like parabolic dishes, another math term. But you would need to know this distance. You would need to know this angle. Do you see what I mean? Where trigonometry comes into play, as you can find angles and sizes of things on buildings in space, and it has also to do with waves, like sonar waves, radar waves, microwaves, and that kind of thing, because of the patterns that it develops. Okay. But anyway, I don't really want to ever do it again. 30, 60, 90 triangles. I don't expect it this year, but there's sometimes when I ask a student a question, I've noticed sometimes they sort of fight what Isabella's mentioned already, the patterns. They'll go to like 120 degrees. They'll draw this. Their reference angle is 60. You're all kind of hanging with me there? And then they'll go, okay, then this one's 30 and this one's 90, and they'll reinvent the wheel. They'll draw all their ratios and figure out sine, cosine, and tangent. And we want to move away from that because you won't have time to do that. The rest of your class is going to go, the sine of 120 is square root of 3 over 2. Let's move on, okay? Just like 3 plus 4 is 7. You'll get good at that. Now, as I'm over here, though, do y'all see that I really need a way to tell somebody where I am, because the sine and cosine and tangent of 120 is really going to tell the user something. And so now all of a sudden you actually see x and y coordinates that are coming into play, whereas you used to just have an angle that wasn't drawn anywhere on the Cartesian coordinate plane, but now we'll be thinking about our bow tie in these quadrants. I'll give you great ways to memorize all of this, okay? A lot of little acronyms and stuff that are pretty standard. Lots of people know them. But do y'all see now all of a sudden the x might be negative while the y is positive? And that impacts everything, and it tells us stuff in physics and mathematics and beyond, okay? So you might actually get some negative ratios here because now it matters where you are around the circle, okay? The unit circle is used a lot. I will show it to you even though I don't probably use it. I learned on the unit circle, by the way, so there's no reason for me to not use it because I learned on it and used it through college. But then when I got out of college and started teaching a workshop or something, I was introduced to the way I teach it now. And I find it much more user-friendly because you only have to memorize one quadrant. You have to memorize all four. And it just seems better to me. But you will also study with people and look at things, and I'll show you the unit circle. And I'm not going to ever care or ask what you're using. So you make a decision. I think a lot of us end up doing a blend of the two. I probably do, okay? But anyway, the unit circle, if I actually say that word, it means that the radius is 1. One reason I'm not a big fan of the unit circle is quite often the radius is not 1. So then what am I going to do? Do y'all see what I mean? And sometimes if I just teach the unit circle, people get hung up on the radius has to be 1. If the radius is 1, let's go to a 45-45 triangle. If the radius is 1, that would be over here, wouldn't it? That would be the radius, would be the radius of the circle is the hypotenuse of that right triangle. And the sides would be what? How do you go backwards? So it'd be 1 over square root of 2, or square root of 2 over 2, square root of 2 over 2, which actually gives you a point out here, positive square root of 2 over 2, positive square root of 2 over 2. It actually gives you a point out here. square root of 2 over 2, square root of 2 over 2. Sorry, those are both positive. Now back to something that Bella and I were talking about. I had teachers that used 1 over square root of 2. I had teachers that used square root of 2 over 2. We'll probably look at help things or study with somebody sometimes that's rationalizing or not rationalizing. I honestly don't care. It doesn't matter to me if it's rationalized or not. There's a few that I rationalize just because it just looks so much better. I'm not a big fan of rationalizing like 5 over square root of 2 because it looks worse rather than better when I do that. I didn't know what 5 over square root of 2 was anyway, but I had a better chance of figuring that out than 5 square root of 2 over 2. So you may sit, you could justifiably be sitting there going, okay, then why do I have to do it? Because if I have this, and I rationalize it, or not that one, I'm sorry. But you see what I mean? That one didn't really get any better. That didn't help me any. If I have this, and I rationalize it, what do I get? Just root 3. So that's a whole lot better than me running around and trying to figure out what 3 over root 3 is. I don't know what that is, but I know root 3 is 1.732. Okay? I mean, you don't have to know that, but I know you can estimate. So if you have any number over its own root, you will see me rationalize that, and I might as well just call it root 5. So in a little while, if I have this, I do rationalize those, and I'll say root 2. If you want to say 2 over square root of 2, that's okay. It's just not quite as efficient. So I'm glad I know how to do it. But if I have 7 over square root of 2, I don't care if you leave it like that. Sometimes you'll give me a decimal, so, or you can rationalize it. You need to know rationalization, obviously, for some ACT questions. But anyway. All right, so now, let me make this bigger so that we can talk about this circle that I have drawn up here. Pretend like that's a circle. Okay, so suppose that the radius had been 4. Then would this be 4 over root 2 and 4 over root 2? Would that be true?
Is it 45?
Oh, sorry. It's 45, 45, 90. Good question. Would that be true? Okay, so what is 4 over root 2 if I rationalize it?
2 root 2.
So it's 2 root 2, which looks a little bit better. So this is 2 root 2 and 2 root 2, which actually is just a multiple of this because the triangle's been stretched. Do y'all see what I mean there? Now, if I find the sine, cosine, and tangent of the first one, sine of 45 degrees. Sine is opposite, which if you can read this little thing, square root of 2 over 2 over hypotenuse, so you get square root of 2 over 2. That's why a lot of people like the unit circle, because the hypotenuse is always 1. And so whatever these numbers are you're seeing, you're actually seeing sine and cosine. Okay? On this one, this point right here, out x, up y, is 2 root 2, 2 comma root 2. These are actually, when you see somebody else's unit circle, these are x and y coordinates. Do y'all see what I mean? To get you to that point. Later in the year, we'll study something called polar coordinates that are really more important, where you turn 45 degrees and just go straight to this point 4 units. You see how polar coordinates are really nice that way? I'll teach those to you later. Okay? But it's nice to just know those are out there. What do you think is going to happen if I find the sine of 45 degrees with this bigger circle? I'm going to say opposite over hypotenuse. It's a little bit more cumbersome, 2 root 2 over 4, but I still get root 2 over 2. Okay? So I just wanted to say, do you see why some people use the unit circle? Because then they don't have to reduce. So it's okay. It's just that every circle is certainly not a unit circle. So with the unit circle, the points that you see around the edge are the ones that you can use. Because you're going opposite over hypotenuse and hypotenuse 1, adjacent over hypotenuse. And opposite over adjacent, okay? All right, now, there's something, another thing, isn't this my x-coordinate and my y-coordinate? So if you see someone's unit circle, you've got to be a little careful because it's not sine, cosine. What you're seeing is actually, right here, I probably shouldn't have used this one because they're both root 2 over 2. But if it had been a 30-degree angle, one of them would be 1/2 and one of them would be square root of 3/2. They would be different numbers. But do you see how this is going to be really come into play big time later today or in the next class? Do you see how this is x and y, and I'm going to call this r for radius? So out x, up y, and then this hypotenuse right here is always the radius of the circle, okay? Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So the first one you're seeing is really your x-coordinate is trying to tell you cosine. So when you see a unit circle, x goes with cosine, so this is cosine of 45 degrees, and this one is your y-coordinate. Look at this, sine. Do y'all see that sine's always going to come from opposite over hypotenuse? Let me draw one over here. I've certainly drawn on that triangle enough, okay? So this is an x-coordinate, a y-coordinate, and would y'all agree that's the radius of the circle, or the three components of my special right triangle, okay? All right, so sine of this angle, whatever it ends up being my reference angle, sine of that is opposite over hypotenuse. Do you see how the sine will always come from your y-coordinate? And cosine of the angle, can everybody see that would always be the adjacent side no matter where I land? If I land in this quadrant, and I find my reference angle, x, y, and r, do you see how, and we'll write this down later. Cosine is always going to come from adjacent over hypotenuse, so it's always going to be your x-coordinate. Okay. Y'all okay so far? So that's a lot of talking, just like, I'll give you something to hold on to, but right now I'm just getting the premise behind us. Did y'all notice in those quadrants, as I'm moving around, it matters what my points would be. Well, actually, we'll call this negative and this negative as we go. Do you see your x and y coordinates could be positives or negatives depending on where you are on your circle? The radius is always positive. Okay? By the way, when I said the radius is always positive, it reminded me of square of the front, put it in the front, square of the back, put it in the back. Stick them together, put it in the middle, the last sign's always plus. Okay, some of y'all didn't bother to remember that. But anyway, why is your radius always positive? What if you all came in today and said, first thing we're going to do is you're going to draw me a circle with a radius of 7, and I give you a compass, okay? Then I say, okay, now I want you to draw me a circle with a radius of -2. That doesn't make any sense. A radius is a distance, right? So that'll help you. Your radius is always positive. Your x and y components, you'll hear that in your physics class, can carry signs with them, positives and negative signs, okay? All right, so let's see if you remember. We're going to do it together, and then we'll start our memo page. See if you can help me do the sine, cosine, tangent chart in degrees. We'll worry about radians later, okay? Does anybody remember what goes right here in this square right here? What angle do I start with? 3, 4, 5, 6. All right, and then it starts 1, 2, 3, 3, 2, 1, 3, 1, 3. The third column has 3 threes. Where's the third one? At the top. Excellent, girls. The first 2 columns are all divided by 2. I usually see this at the top of every test and quiz while we're doing trig. People are like, can I write yet? And they write this down. Then you can look at it like a table. So these are all divided by 2. And then what are you going to put at the top of every one of them? Except the ones. Square root. Sorry, that red may be kind of an aggravating color, but... Okay, oh, that is super aggravating to you. I'm sorry. We'll do it on a clean slide in just a minute with no puppies. All right? So you're about to do this. This is where we're headed. I hesitate to show you this because I don't want you to freak out. But, what I was going to say is really a true story. I, years ago, decided, like hundreds of years ago probably, decided as a teacher, once I liked this method, to go, students want a consolidated amount of information. Has anybody ever seen a smart card like at Barnes & Noble? It's like a laminated card of everything you need to know about biology or the ACT or something. Well, I thought of it before they did. So I should have made a bunch of mine. It'd be like if you had a laminated card on everything you know about trigonometry in one page. But you're gonna create your own, because it's in your own handwriting, you'll probably remember it better, and you know right where it is on your memo page. You cannot bring a memo page to quizzes or tests. But, so it's called a memo page, not a cheat sheet, okay? It's a memo page, meaning it needs to be in your head. How's it gonna get in your head? I can promise you, if you're doing your homework, like really doing your homework, you'll have your memo page out. And while you're doing your homework, you'll go, oh, no, whoa, she's got one. Okay, so like that, but you'll have your own. So I'll show you one. There you go. I'll show you one that one of my students made. I've got it on my website. Girls, listen. When you're doing your homework, as you build your memo page, have it where you can look at it, and you'll find yourself just like anything in life. You'll look back and forth until you realize you're not looking back and forth. Do y'all see what I mean? You know, I'm not even, you could go throw it away, and you wouldn't even know where, you would know exactly what you were doing. You would have looked enough to go, I understand this, I promise. Okay, so just don't force anything, let it happen. I'll kind of help you force it in a safe way. It'll be all on the front page, most likely. I know some of you like to write big and fluffy, so that's just your decision. I strongly suggest, and notice I haven't suggested what you write with, what you write on, or what you put it in. So I strongly suggest that's a big deal, that you either have it at the very front, if you have a composition book, or the very back, or right in front of one of the devices. Have it somewhere where you can find it quickly for homework or classwork, okay? And studying. So just know, you've got to know where it is, hold it down, flag it, whatever. This is what one looks like. And we'll add a bunch to it, okay? So, what I was going to say is, I recommend that you actually keep it for calculus, because over the summer you really might forget some of this, or you're studying for like an ACT, you can pull it out and it's all on one page. You don't have to go flipping through a trig book going, what was that identity that she taught me? Okay? It'll be right there on one page. I've had students as old as 30 years old email me and go, I lost my memo page. Can you send it to me? One girl, Mariana Brazil, majored in like business or something. Then she decided she wanted to be a nurse, but she had to go back and take some science courses. So I get this email from her like, I know you told me to save your memo page, but I'm not married with children and I have no idea where it is. So can you send me a memo page? So I'll email you one without a lecture if you forget yours and find yourself needing one. But she knew that she could look at that and remember everything that we had learned instead of going back and listening to videos and stuff. So it's up to you. It's not something I'll ever check. So in our class, under topics, I think this is Rachel Geiger. She went to Duke. This is her memo page. So I don't have a memo page because it's in my head, okay? So I don't need a memo page. So when some of my students ask for one, I had to send an email out like, y'all send me your memo pages because I don't have my own and I don't want to write one. So this is Rachel's. And so don't be overwhelmed by it. It'll just grow over weeks, okay? But you see kind of how she's boxed things in, and that's trigonometry. That's weeks, if not months of trigonometry all on one page, okay? All right, so here we go. We're going to your memo page. We'll start your first thing. Here's the rules. If you're a note taker, and I will put this on your memo page, everybody pauses, go to your memo page, and you wait until I write it down, and then I box it in, and I step away, and then you put it in the memo page. The reason for that is it can be very frustrating to lots of people. If I'm still talking about the concept, if you're trying to write down everything I say, and it's like, oh, that didn't even always be supposed to go on my memo page. Okay? I'll make it very clear with the box. This goes on your memo page. So right now you're not writing. I'll tell you what, at the top, if you would like, put memo page, okay? All right, so here's your memo page. Getting started. All right. So the first thing that's going to go on your memo page is your 1, 2, 3 chart, okay? By the way, I've got to draw a chart. I'm not drawing a box yet, okay? I will box it in with blue when I'm done. You are not writing. What's interesting about a lot of things you write on your memo page, you'll have it memorized by the time you write it on your memo page, or pre-memorized, okay? So you're going to help me one more time. That's not a box. That's a chart. I think I have too many things. Thank you. All right, so we're reserving this for this radians I keep talking about. All right, so we're going to go 3. That's not loud enough. 1, 2, 3, go. 3, 4, 5.
6. 1, 2, 3, 3, 2, 1, 3, 1, 3, 2, 5, 5. Square.
Okay, thank you, Robert Harris. All right, and so now you've left room for radians, which we may or may not get to today. So put your 1, 2, 3 chart on your memo page. I'll spend time putting my square roots in blue so that I can see them. I'm also going to be passing out a worksheet that we're doing together in class.
I'm so confused on how the square root one works.
What?
How you know this?
Oh, what's the square root of 1? What do you square to get 1?
One.
Yeah. It's just like there's no reason to write a square root over the 1.
Oh.
Is that what you were asking, Nicole?
Yeah.
Obviously, when you're absent, you want to ask one of your trusted friends, did you add anything to the memo page today? So I just kind of do it fluidly. I don't even know if it's in my notes to do it. So always check your memo page every now and then with a friend. Looks like memo page. All right, if you're not finished, hurry up and finish. And if I go on and you're not ready, remember where it was. It'd be easy to find in the video. It'll be the white page that I keep coming back to. Okay? That we will have titles for some things, but if you want to, I wouldn't even title it. You could call it the 1, 2, 3 chart or something, but I don't think this one needs a title. But we will title some of them, okay? All right, I'm going to add something else to it, but I'm going to go back to this. Don't forget, if you're like super careful and you're not through because you're trying to be perfect, you'll see it on the white slide. So, you're not writing on your memo page. Do y'all notice that? It'll be on the white slide when I'm ready for you to write them. Right now, you're just listening. If I rotate around and I find my correct reference angle, to find sine, I could go through the trouble of finding all 3 sides of the triangle, but this is x, this is y, and this is r. Sine of an angle is always going to be y over r. Do y'all see that? You'll very rarely hear me ever say the words opposite over adjacent again. I'm usually going to be referring to x, y, and r, okay? Cosine, who wants to tell me what letters cosine is created by? X and R. We're moving into trigonometry, away from geometry. Tangent of theta is opposite over adjacent. What will it be? Y over x. This is really nice to look at when you're figuring things out. Sine will always be created by y over r. Cosine's the adjacent, x over r. Tangent's opposite over adjacent. I'm also going to go on that does not go on your memo page yet. I am not on the white slide, okay? So if you're just taking notes somewhere else, that's fine. Also, there are 3 more trig words: cosecant, secant, and cotangent. To write them out, this is cosecant. We couldn't call it COS, that was already taken. So they called it CSC, challenge, shape, and change the world. So CSC, secant, and cotangent. Hang on, girls, stay with me. Cosecant is the reciprocal of sine. Do you understand that math language? I don't want to write out the sentence. Cosecant is the reciprocal of sine. What if I wanted the reciprocal of 4/3? 3/4, but how could I really tell you the reciprocals? I could say 1 over 4/3, and what would that turn it into? Do y'all see how that's a way for me to tell you things are reciprocals? What's the reciprocal of x is, oh, I'm sorry, that equal mark doesn't belong there. Those aren't equal. What's the reciprocal of x would be 1 over x, right? So this is a vehicle to tell you that I have reciprocals. That's just a mark to yourself like, oh, if I want cosecant, you'll still just find sine and you'll just flip it over. You don't have to do but one little extra bit of effort, okay? There's not a new way to find cosecant. Find sine, flip it over. Reciprocal. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We're going to put those on our memo page, go into the white slide. Okay, so I'm going to write sine of an angle is y over r, cosine of an angle is x over r, tangent of an angle you will always refer to y over x. It's boxed in. And then, Isabel, we've got a title for the next one if you want one. This is called the reciprocal identities. Meaning that they're identical on either side.
That's the thing you just wrote in?
No.
Oh, that's.
The reciprocal identities are cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals of each other. Tangent and cotangent. Those are called the reciprocal identities. You will learn lots of identities in here, kind of like in geometry, you learn lots of theorems. There will be these things that are always true, we call them identities, okay?
So is cosecant then r over y?
But you're going to always find cosine and just flip it over most likely, but if you didn't want to do that, that would be a way to find it for sure, Bella. She's exactly right. No really reason to write that down since they're probably right next to each other in the chart, but that's very true.
On your calculator, is that just a little sign minus 1?
No. Thank you so much. Girls, it is not, I'm not saying that cosecant is inverse sine. Who remembers when you would push the inverse sine button? You are not flipping something over. That's a great question. You're trying, sorry, there were hands all around you, but you're exactly right. Is that what y'all are going to say? Inverse sine is a completely different thing. You're trying to find an angle. Don't even push that button yet. It's going to be a while before you're looking for an angle. Usually I'm going to give you angles. So Rebecca, fantastic question. I just go 1 over sine if I'm looking for cosecant. Okay? So I just go 1 over what. There is a, I'm just going to leave it there. I don't need to confuse anybody. There's a way to do it, but we're not doing it. Great question. It really brings up a topic of what Miss O'D always calls fluency in mathematics. Fluency. You hear your teacher say things like multiplicative inverse for reciprocal. It's also an inverse function. That's a completely different thing. Addition and subtraction are inverse functions of each other. I'm not talking about flipping something over. Do you see that's like night and day? So that little -1 button above sine, cosine, and tangent, you're talking about a full-fledged inverse function. You're not talking about a reciprocal. You're talking about, oh, I need to go backwards. Squaring and square root. Okay? But that always comes up, Rebecca. I'm so glad you asked that. Okay, now look at your sheet. Everybody, pass those down, Mary. And everybody look at worksheet 1. We're going to do it together. Have your memo page in front of your face. Sorry, that sounded rude. Have your memo page out where you can see it. Oh, here, I thought there would be one left. There you go. Okay, so now you have your memo page, and you'll have it out for every class. Okay, sine of 60. All right, somebody's already found it in their little chart. It's square root of 3 over 2. So, did everybody get number 1 right? Okay. Number 2. Ooh. Secant of 60. All right, I'm going to do this. Secant of 60. All right, now, girls, I'm on the white side, and now I'm just using it like my memo page. I am not adding anything else to it right this minute. I might later, but not right now. I know that, what is it? Let's see, secant. Secant is the reciprocal of cosine. So I'm going to look up the cosine of 60. It's like I'm playing bingo or something, okay? And it's 1/2, so what are you going to write? 2. Okay. So that one is 2. All right, number 3. Tangent of 30. Root 3 over 3. One day you'll know that off the top of your head, but just let it happen. It's like when you learned your multiplication tables, you probably maybe thought you'd never get it, and then eventually you did. Cotangent 60. Okay, very good, thank you. All right, so somebody, hang on. Yeah, I'll go and go there now. Cotangent of 60, you looked up tangent of 60, which is root 3, and you took the reciprocal. It is fine with me if you leave it like this. But delta math's probably going to require you to do it like this when we do some delta maths. Rationalize it? Okay. I don't care which way you write it on the test. Number 5. 5 cosine of 45. Y'all are doing great. Cosine of 45 is root 2 over 2. What's funny is you'll know all of these by test time and maybe by quizzes. But you'll probably most people still write that 1, 2, 3 chart at the top of your page. So, makes you feel better. Tangent of 45 is 1. Number 7. Who's got number 7? All right, Isabel? 1/2. We okay? All right, raise your hand for 8. Okay, Chloe?
2 over square root 2.
You can write 2 over square root 2. That is one that I rationalize because it's just root 2. But I would take either one. Root 2 just looks a little nicer. Is everybody okay? Do y'all see what Chloe did? She looked up cosine of 45 is square root of 2 over 2, and she flipped it over and took the reciprocal. So you see, it sounds like you're using your charts effectively. All right? Cotangent of 45, did everybody get 1? Okay. Number 10. Who wants to tell us the cotangent of 30? Very good, Bella, root 3. You may have looked up tangent of 30 and gotten 3 over root 3. But that rationalizes just to root 3. You got that? All right, number 11. Cosecant of 60. I'm thinking of what? Okay.
2 over square root of 3.
2 over square root of 3. Delta math, if I assign it, will require that. I accept either one. Number 12. The very first thing in your chart. Sine of 30, if you want to anchor, that 1/2 is going to kind of stick in your mind and everything else kind of flows. Number 13, did y'all get root 3 over 2? Number 14, cosecant of 30, 2. And number 15, secant of 30. 2 over root 3, 2 root 3 over 3. Back to Isabel's first statement today. There's definitely some patterns I must be supposed to be noticing that we're just kind of watching happen in front of us, okay? Do y'all see what I mean? Those numbers are happening over and over again. All right, now let's go to the second page. And we'll go a little more slowly. I'm going to add something to your memo page real quickly. So not on the white slide yet. Put your packet down for a minute, okay? And let's go to a different slide. All right, so this is not on your memo page yet. I want to just settle something once and for all so that I don't have to do what I'm about to show you over and over again. Number 1, you're not writing yet, or we'll just go ahead and do number 1 together. Sine of 150. The long way to do it would be go, what's my reference angle? 30. Very good, from your homework, okay? My reference angle is 30. The worst way to do this, the longest way, is then to now construct your 30, 60, 90 ratios, okay? But y'all see, I can now just look up sine of 30. Like, I don't need to do the ratios over and over and over again. They're not going to change, okay? What's the sine of 30? What's the ratio of sine of 30? It's 1/2, okay? No, hang on. The sine of this angle is 1/2. But remember how I gave you that x, y, and r? Because in physics we need to know the placement of this, like what we call, if you haven't heard these words, you will, the x and y components, okay? Sine is what 2 letters on your memo page? Y over r. You can look at it. Isn't sine y over r on your memo page? In the second quadrant, what is y? Positive. What did I tell you r was always? Positive. And so I'm not going to let you right now, but if you got out your calculator and punched in sine of 150, you would get 1/2. It's the same thing as the sine of 30. There are patterns that are going through here. Okay? Now, you're just watching. You're going to understand all of this in just 1 second. I'm going to draw the butterfly bow tie, whatever you want to call it. And this is what you did for homework, finding all these cutesy little reference angles. Okay? This is x, y, and r. Okay? What did I tell you? Oh, don't forget, sometimes us trigonometry teachers forget to remind you these are angles. They're part of a bigger circle. Okay, everybody? All right. In the first quadrant, what do you know about x, y, and r? They're all positive. So I'm going to get the signs. You're not writing this. For sine, cosine, and tangent is not stressful, right? Are y'all okay if I go sine, cosine, tangent? Do you naturally say it in that order?
Yeah.
Because you'll see some things that go cosine, sine, tangent if you are looking at things outside my class. Just be careful. I'm going to always go sine, cosine, tangent. In the second quadrant, sine is y over r. Those are both what? But look at cosine is x over r. That's a negative over a positive, because what did I say about r? It's the radius of the circle, right. All right, and then tangent is opposite over adjacent, or on your memo page, y over x. A positive over a negative, okay? In the third quadrant, sorry, it's not behaving. Okay, in the third quadrant, sine is y over r. What will that give you? A negative. Doesn't it kind of feel funny to call this r positive down there, but it's just the radius of your circle as it sweeps around, okay? What is x? Cosine is adjacent over hypotenuse. A negative over a what? Positive. Tangent ends up being what in the third quadrant? Because you have a negative over, oops, sorry. You have, can y'all see this blue? Not really, but there's some blue there. You have a negative and a negative. Okay? In the fourth quadrant, sine is y over r. You'll get a negative. Cosine is x over r. And tangent is y over x, or opposite over adjacent, negative. Okay, so we now have done it like the 1, 2, 3 chart. You don't have to keep going. If I say find the sine of 60, you don't have to go to your triangle, find all your ratios, figure it all out like you did in geometry. It's in your chart, okay? We're going to know this once and for all. Somebody made up the acronym. I'm looking at where things are positive, okay? All students take calculus. And people say that all over the world. All students take calculus, meaning they're talking about trigonometry signs, okay? Not only that, I've had students when they take quizzes, unfortunate enough to think that's where they're negative and they just have forgotten what the chart means and they remember all the acronyms. This is the axis is a big plus sign. Do y'all see that? It's trying to tell you where everything's positive. So I'm going to draw a big plus sign, not on my memo page yet, and I'm going to write all students take calculus. What will that mean to you is if you're over here in this quadrant, that's going to tell you sign is positive, so by default, the others are negative. So it relieves you of lots of stress. All right, so let's put that on your memo page real quickly. All students take calculus. The nice thing is it goes in the order we usually go 1, 2, 3, 4 quadrants. So that shouldn't take you but a second to write down. And then we're going to go to number 2. All right, so number 2. Was the, oh, you can't do that one yet. And do I have time to show you? I don't. Let's skip over number 2. Let's go to number 3. Does anybody know why I'm skipping number 2? There's no reference angle. I haven't taught you what to do if it lands right on the line. I'll do that next class. Okay, let's do tangent of 390. All right, so most people draw a little picture until they get better at it. What's my reference angle? 30. Tangent of 30. Look at your memo page. Tangent of 30. Root 3 over 3. It's in the first quadrant where they're all positive. Y'all see what I'm doing there? Yeah. All right, let's do one more, then I'll tell you about your homework. Let's go to number 4. Tangent of 120. 60-degree reference angle. Sometimes I'll write myself little notes or draw little pictures so I won't forget like what I'm thinking of. So, wow, y'all are moving fast. Tangent of 120. The reference angle is 60. Tangent of 60 is root 3. And then all students. Sine is positive, so by default, what is tangent? Negative. Okay? So, bring this packet with you to the next class as one of your assignments. The other assignment will probably be some delta math, and it gets as far as I wanted to today because of Becky World. But anyway, expect delta math on this and just bring the packet with you, okay?
Thank you.
Bye, girls. Always bring your memo page. Somebody catch